I'm fine.
I got your messages, so don't mind me that I didn't respond. Sometimes I will read them, but then responding is another thing. But I know it wasn't something urgent, so that's why I didn't respond. Sure. But I saw your
Yes, ma.
messages.
Thank you, ma'am.
Um, let me. I'm not recording. Okay, yes, I'm recording. So this is what simulates packet capture in this environment. You go on that simulator, right? You click on simulation. Simulation will show you how the traffic are flowing in this panel. And then if I start to play it, that means I'm capturing. So it shows you the event that are happening. These are how the packets are moving. This one, I think this is STP packets trying to move. This is STP. Yeah, that's STP packet. So when you do a simulation or you want to capture your traffic, let me say maybe say I'm having connectivity issue. Maybe this router is not able to reach this guy or whatever it is. What I will do is I'll start a packet capture. I will get one of these envelopes, drop it in my source. Let me say I want traffic to go from 10.5 to 30.5. So I drop one packet here, one envelope here. The icon will still have one other envelope because it's two envelope at a go, which is source and destination. So I'm going to drop the other one there and drop the other one there, and then I follow the packet. Now, this is my message right here. I'll follow it as it traverses this. So it moves. I will watch it and see where it gets dropped. If it gets dropped, it will mark bad. So here, it didn't get dropped here. It's still flowing. And then I see that it got here. So the traffic was able to leave this guy and got to this router. And then got here. I see that it made it to the switch. And then from the switch, it will obviously make it because in this topology, I have a very good routing in this topology. So this guy, when you see something like this drop, I want to click it. When you see something like that, as you want to click it and then go through the messages. This will tell you more details about where it is dropped or what happened or why it dropped it. This one, if I go to next, I will see that it says the frame destination MAC address does not match the receiving port MAC address, the broadcast address or the multicast address. Then the device dropped the frame. So I know that this is a broadcast message, probably an app message that this computer received, but because it's not meant for it, that's why I say the destination MAC does not match the receiving port MAC. Because it is a broadcast message, it will check the MAC address destination. If it's not its own, it will obviously drop it. So this is what this message is telling me why this computer dropped that packet. So this is what you're going to look for. When you go here, just keep clicking next layer, read the details. You will see one of them will tell you why the packet was dropped, and then you can troubleshoot from there. Does that make sense? How about you come and get it?
I'm sorry, is there any way we can retrieve any file that was mistakenly deleted? Is there any way?
Believe that from where?
I mean, is there any way we can retrieve unsaved packet trace out saved? Is it possible?
If it's not safe, you can't retrieve it now. Your computer will wipe it now.
Okay. Right.
So you finish designing, you closed it without saving.
Honestly, my system just went into updates.
I mean, you can check recent, see if it will be in your recent files, but I doubt. Your recent files should have the ones that you saved. See if there is, it will be there. That's the only
It's
thing you
not there.
can find. If it's not there, I'm sorry.
All right. Complete again.
All right. So Godswill, where were you? Where were you blocked on your own? What happened? Godswill, please talk to me. Am I alone here? Is he not here? Okay, I think he's not in another meeting, Sha. Samson, you have a problem or just timing issue?
Timing issue, ma.
Okay. All right, so let's go into the business of the day, yeah?
Okay, ma'am.
All right. So,
Sorry, I'm at somewhere and the place I can't talk. That's the problem.
okay, I thought as much.
Yeah, that was why I wrote you earlier, right? So, but mine was saying port not assigned, right? And I followed everything. I could do show VLAN. I was able to see the VLAN tables and also the routing tables, right? But I had to now like start googling and checking on ChatGPT. I saw some places I made mistake, but it was showing me port not assigned. But I don't know what that would mean. But I would have to go through it again.
I wouldn't know why it's showing port not assigned if I don't see the topology. So you submitted that one to me?
Yeah. I actually
The one
submitted
that
it
is
to
saying
you.
port not assigned?
Yes.
Okay, I'll take a look.
Okay. Thank you very much. Thank
Okay, let's go VTP. Who is in VTP? Please. Let's go into the business of today. Today, we are going to be looking at access control list. We're going to be looking at this from two facets of point, from core networking side and the network security side, because they actually do the same thing. And when we start doing the firewall, you're going to be doing a lot of ACLs, because that is one of the main things that the firewall offers you, ability to filter your traffic based on a lot of characteristics. Unlike what a device or a router will give you, a firewall will give you more granular options for you to filter your traffic, which is the main thing that the firewall does for you. So we're going to look at this from the router perspective, but I want you to have it at the back of your mind that ACL is the same everywhere. Access control list is the same on a router, on a switch, on different vendors. It's the same. The difference is the name that they call it in their own. So we're going to stick with ACL for now, which is the name that Cisco calls packet filtering. So let's get started. Now we did. Let me bring up that my topology first. This topology I have here right now. This is topology we are going to use for today's lab. I just finished building this topology. So this topology have VLANs, and we know that by default, computers on different VLANs won't be able to communicate, because that is how we do network segmentation. But then once you do proper routing in the environment, you will see that everything will start communicating all over again. I once taught inter-VLAN routing to a set of students that asked me, okay, if our goal was to segment the network in the first place so that they don't communicate, but once we do routing, everybody starts communicating again. So what is the need of VLAN if all of them are going to start communicating once we do inter-VLAN routing? So one thing is that VLAN is for network segmentation. It is not for security. It's for you to segment the network for easy management. Where the security comes in is when you control who talks to who and who does not talk to who. So once we put a VLAN or inter-VLAN routing, everybody start communicating. So how do we now inculcate security to see how we can filter or take control of who talks to who and who doesn't have the ability to talk to another PC? That is where ACL come in. So ACL is a set of rules used to filter network traffic. Like I said, Cisco calls it ACL. Palo Alto will call it policies. Another device will call it a different thing. So they call it different names in different vendor, but the concept and the overview is the same. So we say it's a set of rules used to filter network traffic. It is used to define what resources a user or a network can access. So you have a lot of people in your network. You want to be able to filter what is it. Cyberpunk, welcome in. So you want to see which of the resources a computer or another network is able to access. Example is if you're an organization and you have a server that is hosted for payroll system, you wouldn't want your entire organization to have access to this payroll system. You want maybe just the HR team to have access to this payroll system. You may have another device that hosts a web server for, not a web server, a file server, where you know that a lot of people need access to the files on this server for them to perform their daily duties. You want to make sure that everybody that needs access to this is able to grab it while still maintaining a kind of restriction for those that doesn't need access to it. So putting in all these policies is what we do with ACL. By default, all users on network can access any resources on network, as you have seen over the time. All the design we've been doing, all the topology we've been building, once there is a proper routing, proper IP address, you see everybody is communicating. So by default, everybody will communicate. This is on a router. In a firewall, by default, everybody is denied. So firewall provides an opposite of that. In a router, everybody communicates by default. In a firewall, everybody is denied by default. Because a firewall is looking forward to dropping your traffic. It's not looking forward to allow you access. While a router is looking forward to allow you access, it's not looking forward to drop you. So both of them are built to do the opposite job until you configure a policy to block them or allow the traffic. So when you configure ACLs or security policies, you can configure it to deny traffic or to allow a traffic. These are the two actions that you can configure it. So it will follow based on what you specified. They may be the source, the destination, and all that, and apply the action that you specify for the traffic. So it may be from destination port, source port, destination and port number, protocols. Any of these can be used to set up the granularity of your policy to allow it to allow or deny traffic. So when ACL is enabled, there is an implicit denial. While by default, everybody is allowed access on a network without any kind of ACL. But once you configure an ACL, any ACL on a router, it triggers what we call implicit deny. Implicit deny means any traffic that you did not explicitly allow is by default denied. So once you set up the ACL, it starts functioning like some firewalls that will be dropping by default. But that means at least one ACL needs to be set for that to kick in. So once you configure any ACL, it triggers the implicit deny. This will force you to make sure that whatever traffic you want to be allowed is explicitly allowed. Otherwise, it will be automatically denied. When we configure ACL on a Cisco devices, we have two types of them. We have standard ACL, we have extended ACL. I think we are going to be looking at standard ACL if I'm right today. Let's see how far we go. Before we proceed, ask your questions. Silence is consent. All right. Now let's talk about these two. Go ahead.
I said no question from my
Okay,
end.
okay. So let's talk about these two ACLs. First of all is the standard ACL. What is the difference between both of them. So for standard ACL, it allows you to evaluate using the source IP address only. So it does not give you the flexibility to specify any other criteria except from source IP address. So you cannot specify the destination IP address or the protocol or any other detail. It's just the only thing it allows you to do is specify a source IP address. So it means traffic that is sourcing from social IP address, wherever you are going, as long as you are sourcing from this IP address, I want to allow or block the traffic. And how does the system know you're configuring standard ACL? Is by the ACL number that you specify. When you're configuring the ACL, you're going to specify a number. If you specify a number between 1 to 99 and 1300 to 1999, the system will automatically know that you are setting up a standard ACL, and it will only prompt you to specify a source IP address without option of destination IP address. And because of this, we apply this ACL closest to the destination so that you don't overblock. We apply it closest to the destination so that you don't overblock or over-deny. While extended ACL will allow you to evaluate both based on source IP address and destination IP address. So this means it gives you more flexibility. You can specify a specific source, a specific destination, and then apply or configure your policy. The system will know that you're setting up an extended ACL if you specify number 100 to 199 or 2699 to 2999. Any of these numbers would tell the system that you are about to configure an extended ACL, and it will prompt you for both source and destination, and even possibly a protocol for you. And because this one provides more granularity, we want to apply it close to the source, because you can specify source and destination. So you can apply it close to the source so that it is being denied or is being worked on as soon as it hits the firewall, as soon as it hits the router. There is one thing we use to configure ACL, which we call a wildcard. A wildcard is just an inverse of a subnet mask. It's called a wildcard mask. When you configure ACLs, you configure, I think, NAT, and then you do OSPF. These three things I know you are going to be dealing with wildcard mask instead of a subnet mask when you set them up. So how do you find a wildcard? It's just an inverse of a subnet mask. So it is derived by subtracting the subnet mask from the default subnet mask. When we say default subnet mask is 255.255.255.255. That's the default subnet mask. So if I give you /24 and say, give me the wildcard of /24, you just have to subtract it from the default one, like we have here. The example here, we have find a wildcard mask of /24 and /29. So you just do the default minus the subnet mask you're looking for. So when you deduct it, you're going to have 0.0.0.255. This is for /24, and then 0.0.0.7 for /29. So when you configure your ACL, you're going to be using the wildcard instead of using the subnet mask. Ask me your question. Ask me your question. Okay, silent is consent. Let's continue. So let's look at the syntax of configuring ACL. So the first one is, of course, you decide the type of ACL you want to configure. If you want to do standard ACL, you have two ways you can configure. You have the number ACL, you have the name ACL. For me, I like using the named ACL because it gives you time to modify it. If you use a number ACL and you want to make any change to the ACL, you have to delete everything and configure a new ACL. But if you are using a named ACL, you can just call up the name and then rearrange it. The difference again is, or not a difference, it's the same thing. Your policies or ACLs are evaluated from top to bottom. So you want to make sure that you have a more specific rule before a generic rule. Because once a match is hit, it doesn't go down to check all of them. It's sequential. If you have an ACL that has about 5 rules in it, the system will start evaluating from the top. Once it hits a match in any of those ACLs, it does not go down to check the rest of them. It just stops. So you need to make sure that when you configure the ACL, you configure them in the order you want them to be hit, having a more specific one before a generic rule. Both applies in numbered ACL and named ACL. So here, if you're doing standard ACL for name, it's just a straight command. Access list, you give your access list number, and then you choose if you're permitting or you're denying. And then you specify your source address. Your source can be a wildcard, meaning it can be a host subnet. It can be a host, which is one computer, or it can be any. When you say any, of course, everybody, all. The same thing with the named ACL. The named ACL is that here you have a sequence number. The sequence number is how it's arranged the order that the ACL is evaluated. So the one with is of course a sequential, it's a sequence number. So number 1 will be evaluated first before number 2. Number 2 will be evaluated first before number 3. Those are the sequence number. That is the only difference here. And then you are able to give your ACL a name here instead of giving it a number. Again, with named ACL, you can edit the rules. With numbered ACL, you cannot edit the rule. You have to delete everything and reconfigure the ACL all over again. That's why I usually don't like using number ACL. Especially if your rule has a lot. If you have like an ACL with about 10 rules, if you want to make modification to one of them, you cannot make modification to just that single rule. You need to make modification to entire ACL with that number. So for extended ACL, the same rule applies. The difference here is that you see the syntax. You have option to specify protocol, and you have option to specify both source and destination. You can also specify the precedence and the TOS. Honestly, I've never specified that because whenever I do ACLs on a router, I try to do basic. It's on the firewall that I can do a heavy ACL because I have more options on the firewall to do ACL, including the user as well. So here I usually do the source, destination, and the IP address. And the protocol. So the same rule that applies to standard applies to extended when it comes to the number ACL and the named ACL. Now, one thing is for you to set up the ACL. Another thing is for you to apply the ACL. You can configure the ACL. If you don't apply it, it doesn't kick in. So you need to, first of all, set it up. Second, you need to apply it on an interface. when we apply it on an interface, we have two directions you apply it. Is either you are applying it in the in direction, which is the ingress direction, or you're applying it at the out direction, which is the egress direction. You can configure this and do very, very good. Hey sis, welcome in. You can configure this and do very well, but if you apply it in the wrong direction, it could make the whole difference. Because the application will decide how the system is going to handle it when it comes in. Are you applying it as the traffic is leaving the system, which is the out? Or are you applying it as the traffic is entering the router? If you apply it in the wrong direction, you will get a different outcome. So configuring it is one thing, applying it in the direction that is right is another thing. Ask me your questions. Ask your questions. Okay, let's continue. Let's look at a small example of standard ACL. This one says, this has a full network. It says access ACL, sorry, standard ACL to deny 10.10.10.0/24 access to the network 192.168.10.0/24. So we want to deny a whole network from accessing a whole network. This is a full subnet. And of course, standard ACL only provides you option to specify the source address. So here, the 192.168.0.10.0/24 does not matter in the configuration. What it matters in is when you apply this on an interface is where it matters. So the ACL for this is just giving an ACL number 10. We are denying, and then we are specifying the source IP address 10.10.10.10/the wildcard. The wildcard is 0.0.0.255. Remember, we say once you set up one ACL, implicit deny kicks in. So you want to make sure you include the last command to permit everything else if you are configuring a deny policy, because everything you did not specifically allow will be denied. That is the job function of that second rule you see there. Access list 10 permit any. So here we know that we are only denying 10.10.10/24 network. Everything else will be allowed. If you miss that permit any, everybody will be dropped because implicit deny will kick in. Then applying it in the router depends on where you want to apply it. Now remember, you need to also choose the router where you even set up the policy in the first place. For standard ACL, we say we apply it closest to the destination because we don't want to overblock. Let me pull up my board. People usually informed when it comes to applying these ACLs. What is that? Okay, let me share my board and then we'll walk through this application thing. Reshare screen number 1, screen number 2. No, find my board. I'm trying to find my board. Just give me a moment. Let me find it. Let me know when you can see my board. Let me know when you can see my board.
I can see it, ma'am.
Okay. Now let me say we have, what's going on? This board is not responding. This one is for quick. Okay, let's delete this and make this a little tinier. It's a little tiny. Yeah, this one is fine. Okay, so let's say we have a router here. This is router 1. We have another router here. This is router 2, connected to the third router. This is router 3. And these guys have 2 networks connected to them. This is network A. This is another network here. This is network B. These guys have one network right here. Network C. And my dude here has another network right here and another network here. Now, that I'm drawing all these switches does not mean that all of them have to be switches. It may be a VLAN. There may be a VLAN in one of them that is, separating into three networks, but let's just take them as individual switches. Network D and network E. Now we have this topology now, and we want to configure ACL. Right now, we want to configure standard ACL, which only allow us to specify based on source address. So let's say the rule is block network A from network B. The rule is network A is sitting here, network C is sitting here. We want to block network A from accessing network C, but we still want network A to access network B, network D, and network E. We just don't want it to access network C. And we are dealing with standard ACL. Standard ACL only allows you to configure based on source address. So whatever you're writing or whatever policy you're writing will only be having the IP address of network A as a source. It doesn't care about the destination because you don't have that option to specify it. So we have this topology. The first thing is to decide. We already know the kind of ACL we are writing, standard ACL. The second thing is on which router are we configuring this ACL? Because we want to make sure that network A is still able to access network B and access network D and access network E. The goal is just to block network C. So you need to make a decision of which of these 3 routers is the best place to configure this so that we do not block A from accessing other networks. Bearing in mind that you are only allowed to specify the source address in the policy. So we have 3 routers. That is the first decision you need to make. Which of them is the best one to write it? Now, let's start from router 1. If we write this policy in router 1, that means we have 3 interfaces here. Traffic from network A to network C will flow this direction. It will leave the switch, hit this router will hit it here, and this guy will hit it here. And this guy will send it into this place. So traffic from here, this is the only route it will take. If we configure this policy here, that means our policy will just be deny network A. That's the policy because we cannot specify destination. So if we configure it here, let's say we decide to configure it here, and we have this router interface where the traffic enters the router from and where it leaves the router from. That's what we mean by in and out. When it's entering the router, this direction is in. When the traffic is leaving the router, this is out. So you need to consider in which direction are you going to apply it if you configure that policy on router 1. If we choose to configure it here and decide to apply it on this direction, on this interface in the in direction, of course, when it's entering the router. So it means that any traffic that is entering this router, as long as it is sourcing from here, will be blocked. So this router will now block network A from accessing network B, network C, network D, and network E. Because once the traffic enters here, this router will drop it. It won't even make it alive out of this network, out of this router. So you see, this makes this router the wrong place to configure this traffic, because we are going to be blocking this guy out of the entire network. Ask me your question.
Halima,
Go ahead.
I thought you said that the ACL is it should be configured close to where the source address is coming from, which is the R1. Does that mean that the best
Configure
place?
closest to the destination.
Okay, closest to the destination.
Yes.
Okay. Okay.
And if you decide to configure this guy on this router and apply it here on the out direction, this traffic can never hit this router in the out direction, because the traffic is sourcing from here. So if it sources from here, it will go here. You will never get a traffic that will be going in out that will be leaving this router and is sourcing from this network. That traffic will never initiate. So applying this in the out direction here is a wrong direction. Let's say we apply it on this interface that connected it, because you need to apply it on the router where you configured it. One of the interfaces is where you will apply it. If we apply it on this interface in the out direction, so this traffic will hit this guy, right? And then once this router finishes protecting it and is about to send it out of this interface, the traffic will be dropped. So it means this guy will be allowed to access network B because the traffic will not affect here. The router must have finished processing it, and in the process of sending it out is when it will be dropped. So this guy will be safe. But then if you configure it here, the traffic will never make it to this router. That means network C, network D, and network E are locked out. If you decide to configure it in the in direction, this traffic will never hit this router in the in direction. For the same reason, it will never hit this interface in the in direction. So that would be a wrong direction to apply it. Okay, we evaluated that this router will not be the right place to configure. So let's take it out. We'll come to router 2. Our goal is to block this guy. If we configure that policy here, and the traffic, of course, coming from here will go here, and hit here. So if you have 2 interfaces, either you configure it when it is entering the router or when it is leaving the router. If you configure it on this router and you apply it on this interface when it's entering the router, then it's the same thing as applying it on this router when it's leaving the router. Because once it hits this router, the router will drop the packet. It won't even make it alive out of here. So this guy is blocked, this guy is blocked, this guy is blocked. Now, the other interface is here. Traffic that is going from network A to network C. What reason will make it go past this router and keep moving? Why will it do that when the destination is here? So if traffic from network A going to C passes this router and go this way, that means there is a routing problem somewhere. It's not supposed to be so. It's supposed to go into the network. So if the traffic ever made it out here, it means you even have a routing problem. So we're left with this interface. If we apply it in the in direction on this interface, meaning we configure the policy here. So the traffic will leave here, hit the router, and this router will do its job, hit this one. There is no policy here blocking it, so it will enter this router. The router will work on it, and then in the process where it's about to send it out, in the out direction, the traffic will be dropped. That means this guy is safe. The traffic, of course, will make it here. So this guy will be able to still hit here, will still be able to hit here. So if we configure it on this router and apply it in this interface in the out direction, we may be able to achieve our goal of blocking only this guy. Of course, if you think about configuring it here, I don't know what you're doing in this class. Because why will you configure it on this router? The traffic from here to here is not going to be hitting this router in any way, unless you have a routing problem somewhere. So you see that the best option we have is on this router in the out direction. That's why we say you configure it closest to the destination. This is our destination. This is the router that is closest to the destination, and we are going to apply it in the out direction. If you apply it in the in direction, this traffic will never hit this router in the in direction. You will not get a traffic that source from network A hitting this router in the in direction. It doesn't exist. So you see, from the analogy, we see that the best place to configure this is router 2, and then apply it on this interface in the out direction. Ask me your questions. Ask me your questions before we continue. See the things that you need to consider.
Can you hear me?
Go ahead.
What if there is a redundancy before we get to that network C? I mean, there are two cables that lead to connection that leads to this network C. Does it mean that we're going to connect the ACL bit like on those two lines that are connected to network C? Is that what it means?
Redundancy. What kind of redundancy?
Like this network C now, let's assume there's a connection between the first switch to the network C and also the second switch to the network C. We don't want the address, we don't want the traffic to get to network C.
You mean this kind of connectivity?
Yes, ma'am. Yes,
with
ma'am.
a layer 2 switches?
Yes, ma'am.
On different networks?
Yes, ma'am.
Now you tell me, do you think this traffic will pass? These are layer 2 switches we're talking about. And the computers here are on network B, which is a different subnet. This guy is on a different network, on network C. So what will make IP packets pass from here to here? It's not possible.
I'm talking about from the switch, not from the network, from the switch. I mean, there's a two. Okay.
This is layer 2 switch. Oh. This is another layer 2 switch, right?
Okay.
This
Sorry. I'm talking about the the router on top, the R1, the R2. So what I'm saying is, what if there's a connectivity between R1, NC, and R2 and NC? I mean, R1 and the network C, R2 and network C. Then traffic coming from the R1, once it's
like
initiated,
this.
exactly. Is it possible? Is it the ICL? Are we still going to integrate it on those two lines, those two connections?
Why would somebody make this kind of connection on a layer 2 switch? If it's a layer 3, I will try to understand. Let me think about it. So if you have this is, let me place a firewall here. Firewall will make me visualize it better. So let me say these are firewalls.
Okay.
And then I want to make, maybe is an HA connectivity between this guy. I want to do HA between these two firewalls, and then I need to connect both of them to one switch. Okay. So that they belong to one switch. All right, if I have, okay, this kind of connection is possible. Let me delete the firewall, but that is what will make me visualize the possibility of that. So what will happen in this situation is, what IP do we have here? Do we have an IP here? And what IP do we have here? Because remember, this is a gateway to these networks. So if you
Yes,
have if this is a redundant connectivity, of course, one of them is what will be up at a time. Because you cannot have the two of them up at a time if it's for redundant purposes. So because what you're saying is, if this route goes down to reach this guy, let's use this route. There's a possibility that you have the same IP on this interface and this interface. So one of them is what needs to be up. Two of them will not be up. And if also, if you have on a switch, normally, if you have a switch like this, if you have one switch, right, and I have a router, and I do a redundant connectivity to this router, like this, right?
Yes, ma'am.
STP will kick in here and block one port.
Okay.
So STP will kick in, block one port, leave one port in forwarding mode. Once one goes down, this guy will come up. Unless if you are bundling this as aggregate interface, ether channel, which in that case, the system will see it as one port, not two different ports.
Okay.
So when you have it on different routers like this, it's obviously for redundant purposes. One of them will be down, two of them is not going to be active at the same time. So that if one goes down, one of them will kick in and come up. So the only thing you need to do is to configure the same policies on the interfaces, both of them at the same time, so that anyone that is functioning will still be able to be blocking the traffic from going in. But the thing is that you need to configure the policy here and configure the policy here, and then apply it on the interfaces. Does that answer your question?
Yes, ma'am.
Okay. So let me clean up this. Godsby, ask me your questions, please. Okay, I think he's on another call. All right, so that is it about that one. Let's try out another scenario. Before we go and configure this, let me delete this guy. Let me delete this connectivity. I don't want it. Clean up this a little. No, don't do that. All right. Okay, so let's try another scenario here. Let me say the goal is to block, wait, I need to block this. The goal is to, let me see. Let me say there is a computer plugged on network E, one computer, maybe a server. This is a server. And we want to block network B from reaching just the server, reaching the server only. So if I have another computer plugged here, I still want network B to access it. I just don't want network B to access this server alone. But it can access other computers on network A. This is network B. And also, of course, the network B can still access network A, network C, network D, everything in network E except from this server. So let's walk through how this one will be. And we are dealing with standard ACL. We know that with standard ACL, we are only allowed to configure. Can you stop doing that? Under ACL, we are only allowed to specify the source IP address. But you see, in this case, we need to be more creative when creating this policy. Network B is right here. We want to block access to only this guy. And whatever we do, we need to specify just the source IP address. Now, let's jump the issue of finding the router. We already know that we are going to be configuring this on the router closest to our destination, which is router 3. So let's say after analysis, we decided this will go into this router. But how do we configure it? If we put it on this interface, Y is entering the router, of course, D will be blocked and the entire E will be blocked. If we put it, Y is leaving the router on this interface, this traffic will never exist because you will never get a traffic that is sourcing from here going this direction. So if we come here and we put it in here, in the in direction, that means everything going into this network will be blocked. If we put it in the out direction, this does not exist. Of course, I don't want to consider this interface because we have no business with this interface. So another thing is with standard ACL, you cannot block based on a specific server. Or that means the destination is a specific IP address, because we need a policy that will tell us to block only this server while allowing this entire network. And you can only write that kind of policy with extended ACL. So implementing this will not work with standard ACL. We need more than just one rule to achieve this. We need to set up the first policy that will allow this, which will be the specific policy, or we need to set a first policy that will deny this traffic from this server and then allow access to every other person on this. So we need a policy that will allow us to specify destination IP address. With this kind of one, standard ACL is not a good option. So that is why I say the first thing you do when you receive a policy is to decide which kind of policy is suitable for this job. If the policy is to block an entire IP address, entire subnet, you can be dealing with a standard ACL. But when it comes to block some and allow some, know that standard ACL will not work. So that is how you detect or you decide what kind of policy you are even writing in the first place. Because when the when the instruction comes from the management, they won't be the one that will be telling you on which router you will configure. It will come like, we need to be able to allow access from so people to so people. You, the technical person, is the one that will convert their words into commands that you will type into the system. So you need to find a way to transform whatever they said into a command that you will put in the system to allow it to work through. While you're translating their command is when you decide what kind of policy is suitable for this job. Are we doing standard ACL or are we doing extended ACL, depending on how the instruction comes. So you have 3 requirements when you're doing with ACL. When the instruction comes, first of all, you decide which kind of ACL am I writing. Number 2, on which router am I configuring it? And number 3, which direction am I applying it? A policy applied in the wrong direction is as much as a policy not written. A policy applied in the wrong interface is much as one not written, because you're going to get a different outcome when you don't apply it the right way. Let's go back to our packet tracer and see what we got. Unless somebody has a question, please go ahead and ask. All right, let's keep going. I'm going to reshare my board. Screen number 1, screen number 2. Let me unplug this board for some time. Okay, let's go ahead and write this policy. I will pull up my packet tracer right here. So we have this. Let me just explain this. I just finished building this, so I've not even tested it if it's working properly. So I have VLAN 500, VLAN 600, and VLAN 700, which I don't even know if I configured, but it's fine. So the IP address for VLAN 500 is 10.10.10/25, which I labeled network A. So this 10.5 and 10.10 belongs to network A. Then we have 50.5 and 50.10 belongs to network B, which is VLAN 600. Then this represents my DMZ. Of course, I didn't configure any VLAN here because both of them are already on the same network, so I didn't bother doing any network. But these guys are already doing SVI behind the scene here. And they can communicate. I have done my routing here. This network can talk to this network. This guy can talk to this guy, because I've done my routing and I think everything is working. Let me try again. Yep. So now let's try to write some policy, a standard policy here. Let's write some standard policy here and see. Let me grab this. Let's say, let me think about a policy that people will give me the command I will type. Okay, let me say I want to block or deny network A access to DMZ. Deny network A access to the DMZ. So right now, what represents my DMZ is this part of the network is my DMZ. So the network A is this computer and this computer. I want to block access from this network A from accessing anything on my DMZ. Right now, of course, they are going to be communicating. Let me do continuous ping. Ping minus t 10.10, sorry, not 10.10. 172.16.30.5. So this is a communication from network A to my DMZ. I'm going to leave this ping running. I'm going to leave this continuous ping running here so that when we block it, we'll come back and see if the communication is still going through or not. But before then, let's decide what we are doing, which router. From here, we already know we are going to be doing standard ACL, because that's what we are treating right now. So the next thing is, on which of these devices are we going to configure it? Are we configuring it on the multi-layer switch or on the router? Simeon, where do you think we should configure this? So that because the goal is first just for network A, not to access DMZ. We still want it to access network B. We don't want it to drop network B. So tell us, where do you think we should, on which device do you think we should apply this? Or we should configure it first? I'm waiting for you. Are you thinking about it or you did not hear my question? Which one?
Okay, we are configuring it on the access switch, the second switch.
Give me your reasons why we need to configure it on the access switch.
Okay, because that's the closest router to the destination.
Now this is our destination now.
Yes, yes.
Okay, and we want us to configure it here. I will configure it too. I'll configure it. Just tell me the rule. Give me a minute. Let me bring up this network I'm trying to add here.
Okay.
I don't want to do VLAN, so I'm just gonna label this guy. Let's do label network C and give it subnet of let me give it 10.10.100.0/24 right there, and I can, what interface is this? G0/0. So I can go here and configure the interface EN. Wait, did I say G0/0? Yeah, G0/0. Config T interface G0/0. No shorts. Give it IP add 10.10.10.100.1 255.255.255.0. The interface should be up right now, right? Yes. So this computer connected to this, I'll just give it an IP address. 10.10.100.5. Subnet mask 10.10.100.5. Subnet mask 255.255.255.0. This is 10.10.100.1. All right, I just plugged the new network here. This is network C. Oh, sorry, this is /25. I already configured 24. Let me just change it to 25. All right, okay. So you say we are doing it here, right? Simeon, on mute and talk to me.
Hello, can you hear me?
Yeah, I can hear you.
Yes, ma'am.
So you say we are going to configure it here. That's okay. So
No. I mean the second switch, the access switch. The
this
second
one.
Sorry, the router rather, the second router.
We only have one
Yes,
router in this topology. This router.
Okay. No, since this is a multi-layer switch, it can also route. The first one is a multi-layer switch.
Tell me, where do you think is the best device to configure this policy? We want to deny network A from accessing DMZ. Where is the first router? Are we configuring it on the multi-layer switch or are we configuring it on the router? Because that will decide which of the interfaces we are going to apply it on.
We are configuring it on the router.
Okay, so configure on the router. Let me write it down. Policy on the router. So where are we going to apply it? This router has 3 interfaces. This is G0/1. This is G0/0. This is G0/2. Which of the interfaces are we going to apply it on?
G0/2. Hello, can you hear me?
I can hear you, but your voice is fainting a little. Go ahead. You're muted though, in case you're talking.
G0/2. Sorry.
Okay, we are on G0/2. In what direction? In or out?
In direction.
So apply on G0/2 in direction, right? Okay, so let's go ahead and set the policy. So if I open this guy, make it a little smaller. Get it from this interface. So we are doing, just a moment, let me grab something. Okay, so we are going to be doing access list. Since we are doing, what do you call it? Standard. I'm just going to give it number, anything. Let me give it number 50. And then you say we should deny it here. So we have deny network A. Network A has an IP address of 10.10.10.0. What would be the wildcard of network A? This is /25. What would be the wildcard for it? What would be the wildcard for that?
Is it going to be 2? No, sorry, 1.
What would be the wildcard mask for /25? We are trying to set up the policy. We need the wildcard mask instead of the subnet mask, remember?
5. Okay, 8.1, 7. 7.
For /25. What is the subnet mask for /25 first? Let's start from there.
That's 25. Sorry, that's 128.
Okay. So what would be the wildcard mask for that?
That's 255 minus 128. Sorry, that would be 27. 27.
So 0.0.0.127.
Yes.
That would be the wildcard mask. And then remember, we need to include our explicit allow. Otherwise, everybody will be blocked by this policy. So we have access list number 50, permit any, right here. So if I do show run, you will see the policy we configured right here. But see, we have not applied it. And you say we are applying this policy on the ET interface in the in direction. Let's do that. So go into interface G0/2, apply this IP access group. The policy is number 50, and you say we do in direction. Okay. Do show run. This is us on the G0/2, applying it on the in direction. So let's go and test if it stopped working or not. Okay, the policy is still going, the traffic is still going, it didn't drop. We are pinging this computer .5 from 10.5. This is 10.5 on network A, so it did not drop. We are still able to ping it. Means we did something wrong. Simeon, you want to try and fix that?
Can you hear me?
What do you think went wrong? We configured it on this router.
Okay, we're supposed to.
And we applied it on this interface in the in direction.
Okay, it should be the interface going to the router. I just guess.
Your volume is a little low. Can you? I don't know.
In the in direction going to the router, I mean the 0/1 interface.
This is 0/1.
Yes, probably.
Okay, you want us to apply it here instead?
Yes.
On the in direction?
I don't know.
Tell me what's in your mind.
No, since you said if we are making use of the standard ACL, we make use of the closest router to the destination, and the destination we are pointing at is this network.
Okay, that these guys still have to access. So the goal is just to block from here. We want them to still access this guy.
Okay, if you are blocking for your now means we are going to be doing the out direction, not the in direction, from starting from the interface coming from that switch upward.
This interface. Is it this interface?
No.
This interface.
If the in is not working, then we try the out.
Now you're being political. And now you're being political with it. Okay. Let's see. Let's apply in the out direction and see. But before that, let me bring up another access to this guy, making sure that this guy is working, because we just want to make sure only these guys are blocked. So this computer is still on the same network, on network A. So let's try to send the continuous ping to PC4, which is on this network. Do ping -t 10.10.100.5. Let's see if this guy responds. We want to make sure that both traffic are working. Okay, so this is one traffic going to network C. We don't want this network to drop or this connectivity to drop. This is the one going to DMZ. We want this one to drop. This is one we want to drop. We don't want to drop this guy. So let's go. Right now, both of them are working. So let's go and reconfigure the router interface as you said. So we'll go back. We are already in the interface. So let's take out the one we applied. Put a no in front, take it out, and then reapply it. But this time around, do it in the out direction. That's what you say, right? Before I hit it.
Yes, ma'am.
Okay. Let's see if anyone drops. Voila, this guy dropped. And this guy is still going. So it looks like we got it right this time. So now the traffic has been dropped from our DMZ. So anybody going from network A, which is this PC or this PC, going to any of these, the traffic is expected to be dropped. But we still want them to access this VLAN. and this network, which we confirm that this guy is working. Let's confirm that they are still accessing this VLAN though. Yep, the VLAN, the other VLAN is still working here. So that is one policy applied in the right router in the right direction. Ask me your questions.
Why is the in not working?
Let's review that. So we want to drop traffic going from network A that will be sourcing from network A going to this guy. Traffic that will source from here will hit this switch in this direction, in the in direction, and enter the switch. And it will leave this switch in the out direction here and then head to this router. The traffic will enter the router from here in the in direction. This is the in for this. So when you hit this switch and you want to get to here, it will leave this router in the out direction. When you say in, it means that you're saying that this traffic is sourcing, this source IP is entering the router from here, which is not true. Traffic from network A will never enter this router from here. It will always enter this router from here, but it will leave this router from here in the, or it will leave this router from here in the out direction. The only traffic that you can do in the in direction on this router that will work is this traffic sourcing from this network, because it will enter the router from here, or this traffic that will enter the router from here. But any traffic sourcing from here will never enter the router from this interface or this interface. It will enter from here, which is the in direction. And traffic from here will leave this router out direction here or out direction here. So it's important you understand the flow of traffic. That is one of the, what do I call it? The required skills when you configure ACL, the direction of the flow. So do you understand why the in did not work?
Yes, ma'am.
Okay. Ask your questions, please. Ask me your questions. Let me see if I have any question from here. Gospel, are you able to talk? In case you have a question or before we proceed. I would have loved you to give me a network, or give me the next one I need to do. Gospel, are you able to talk?
Yes, I can talk.
Okay, good. You have a question for me or no?
No, I was actually gonna pick the
Okay.
in, right? But I now understood why you chose the out.
Why I chose what?
The out, like as Simeon was
Why we
responding, I
did
now
out
understood.
instead of in.
Yeah.
So the traffic was sourcing from this network, or not from this computer. When you say source and you follow the flow of the traffic coming from here and want to get to here will move from this. It will first of all hit this switch.
Yeah.
From this switch, it will hit this guy. If your source traffic from here, it will not come and start from here and enter the router from here.
Yeah.
It needs to move on the right direction through the wire. So it will always go from here. It will enter this router or this multi-layer switch from this interface. And then when this guy is done processing it and is about to send it out, it will not send it out from the same interface he received it, of course. So it's either he's sending it this way or is sending it this way.
Yeah.
So traffic sourcing from this guy will leave the router, which is out direction, either from this interface or this interface.
Yeah.
Traffic sourcing from here will never leave the router from here. It will only enter the router from here because this is the source. The routers, traffic that leave from the router are destination traffic, not source traffic. Source traffic enter the router. They don't leave the router. So traffic from here going to here is not going to be entering the router from here because this will be the destination. It's going to be exiting the router from here in the out direction. So when you say in, you're saying that this traffic is entering the router from here, which is not possible. But it cannot be sourcing from here and then be entering from here. When you understand the flow of traffic. Does that make sense?
Yeah, perfect sense. Yeah.
Okay.
Can you hear me?
So give me your own.
Can you hear me now? Hello?
Go ahead.
Okay. Okay, does it not mean that the condition that
your volume is a little low, Simeon? I can hardly hear you.
Hello?
Yeah, that's better.
Okay, doesn't that mean that the only condition that allows us to use that in direction is only if the source is directly connected to the router? For instance, this first VLANs, if you want to block the traffic from not entering the next VLANs, that means it's going to be in, right?
Will still, if you want to block, let me say these interfaces are trunk interfaces, so they're layer 2 interfaces, by the way. So
Okay.
let's assume that layer 3 interfaces now, and I want to block, maybe let's assume these computers here is the one network, these guys are one network. I want to block this computer from talking to this computer, right? So computer network coming from here will hit this switch and enter the router here. If he wants to talk to this guy, he needs to leave the router from here into this network. So if I'm going to block this guy and I'm using standard ACL, it's still going to be the same thing. I'm going to be applying the traffic and I want to block only this guy. I'm going to be blocking it on this interface as the traffic is leaving this guy, which is the out direction.
Okay.
Because traffic sourcing from here will not be entering from this interface. It's going to be landing from here.
Okay. So under what condition do we make use of the in? If we are not going to be... Huh?
Yeah, if I want to block this network now. Okay, let's take one example. On where you will use in with a standard ACL. Let me say I want to deny network B access to all other networks. Deny network B access to all other networks. If I want to write this kind of policy now, so let me say network B has been isolated to be under attack, or there is an infiltration going on network B, and you want to isolate it for IR incident. So you need to isolate it from the entire network so that there will not be a lateral movement or privilege escalation that will get into other part of the network. So what organization will do is they're going to isolate that network immediately from the rest of the network, which is blocking every traffic that is coming from that network from going anywhere. That's how they will isolate it. So let's say we want to isolate network B from the entire network now. So we don't care where it is going. As long as the traffic is originating from network B, we don't want it to reach any computer on the network. We don't want it to reach DMZ. We don't want it to reach network A. We don't want it to reach network C. We just want to isolate the network entirely. So in that case, what you will do here is you got to block this as soon as the traffic is generated and is entering the router. As soon as it's generated and entering the router, we don't care where it is going. So we are going to block the traffic once it hits the router. So that, if that's the case, you can apply the traffic in the in direction, because We don't care where it is going. We want to block it from everywhere. So you need to identify the traffic or the router where the traffic is originating from. And then in that router, you block the traffic as soon as it hits that router. So in this case, where I'm going to configure it is I'm going to configure it on this multi-layer switch, and I'm going to apply it on the VLAN interface of network B in the in direction. As soon as it hits that interface, let it be blocked. So it means once he enters the router, even before the router processes it to know where it is going, it goes ahead to drop it immediately. So in that kind of scenario, you use the indirection for standard ACL. Where you will use indirection mostly is when you do extended ACL, because extended ACL, you're going to be blocking closest to the source. So before it even enters the router, you want to block the traffic. So you're going to be doing in a lot when you do extended ACL. But that does not mean you will not do out, but mostly you will do in. So if I want to block this traffic now, I will configure it on this switch. Let's go ahead and configure this on this switch. Do en config t, do IP access list. Let me give it a access list number 100 and give it a deny the network B, the entire network B. I'm just going to use 10.10, or I'm just going to do deny any, because I'm going to make sure I'm blocking it on that network. What did I do now? Did I type a wrong command? Now. Oh, sorry, the IP I put in front, sorry. Access list 100, deny any. So I can configure this policy. Why is it not working? Access list 99, deny any. Okay, so that number was for extended. That's why it was failing. So now I've configured this policy. I want to deny any. I already know that this is a standard ACL. The any I want to deny is anybody on network B. So I will go into this, go into the interface of network B. Remember, this is a multi-layer switch. So I'm not going to be configuring it on this interface because this is a trunk interface. I'm going to be configuring it on the VLAN interface that we've configured for this guy. So I'm going to go into the VLAN interface. Do network B is VLAN 600. But before that, let us start a communication from network B. Going to anywhere, let's say here, do ping -t 10.10.10.5. This is network A. So let's let this guy run. Right now, we configured the policy, but we've not applied it, so it doesn't take effect. So let's go ahead and apply it on the VLAN interface. Go to interface VLAN 600. Is it 600? I think it's 600, yeah. So do IP access group. You want to apply policy number 99 in the in direction. Once it's entering the router, we just want to drop it. Hit enter. See, these guys start dropping immediately. So now we've locked out this network from communicating anywhere on the network. This network B won't be able to communicate with network A, DMZ, or this network C. We have blocked it from the entire network, and we use the in direction. So where you use the in or out depends on the kind of policy you're writing. There is no rule that says if you get this one, use in, or if you get this one, use out. It all depends on the requirements for the policy that you're writing. Does that make sense?
Sorry. So what's that the difference between this policy and shutting down the interface?
Honestly, there's nothing different from it.
It's as good
Because
as shutting down the
that's what it
interface.
seems like, actually. But the thing is, if you still want to manage that interface, maybe you need to access something over that network remotely. You still want the interface to be up. Maybe there is a console cable connected to the switch or the router, and you still want to access the computers within that network. You still want the interface to be up because the communication will still exist within the network, but it's just that they will not go outside the network. So if you are relying on a connectivity, maybe a VLAN management on the multi-layer switch to reach that network, you're going to need the cable to be up. I know switching up the interface or unplugging the cable seems like an easier thing to do. But you do that only when you are having immediate attack that you know that will take you time to configure policy for. Just put the cable.
So which one is now the best practice? This one or shutting out the interface?
It depends on what you're doing. If your system is currently under attack and you notice that there is somebody on the network, right? And accessing the device will take you more time. Just put the cable. Put the cable and give it time to die out. Then after some time, you can now make a different access opportunity to access the switch without connecting it back to the cable. It all depends on the scenario you find yourself in. The incident response you're doing, that's what determines how you approach it.
All right.
Okay, let's configure one more policy before we go. Let me think of another policy. By the way, let me go and unblock this guy. I beg. I don't like being that wicked. Okay, so that's out. So let's configure another one. Let's say we want to block, or let me do allow this time. I don't want to deny. Let's say allow network C access to network A only. Now we want to allow network A. I want to see a way to reward this, but okay, let's leave it like this. When we do extended ACL, you will see where we write multiple policies in one ACL. So let's leave this one like this. Now, God's will tell me, we want to allow network C, which is this network, access to network A, which is VLAN 500, while blocking any other one. So we want network C to access only network A, and we want it to block any other network. So tell me, you have three things to tell me. I mean, two things, because we already decided we are doing extended ACL. So which router are we applying it on, and on which interface are we going to apply this? Then in what direction?
Okay, we're not talking about extended, no longer standard ACL.
No, we're talking about standard. We have not done extended.
Okay. So we'll still go to the layer 3 switch now, right?
Layer 3 switch, okay.
Yeah.
So policy on multi-layer switch.
Yeah.
So which interface are we going to apply it on? We have, remember that this guy is an SVI. There's an SVI running here. So we have interface VLAN 500 and interface VLAN 600. Don't worry about these are layer 2 interfaces.
Yeah.
So are we applying it in which of the, is it the interface VLAN 500 or interface VLAN 600 or on this physical interface? Where do we apply it?
We are applying it on interface VLAN 600 since we want only VLAN 500 to be able to communicate to network C, right?
We
So
want
that
it
will be
to, we want to allow network C access to network A, which is
network
VLAN
A.
500.
Yeah.
So which
So
interface?
we should deny interface VLAN 600 so that it will not be able to
Okay, so the
then
first
get
policy is
impacted.
to, you say deny.
Yeah, the interface for VLAN 600.
So the one first is to configure the policy. Application is on one interface. You can apply it on two interfaces. So the policy may have multi-rules in them, right? But then the application will be on one interface. So if you say we need to write a policy to deny VLAN 600, that means it's a rule. One of the policies we're going to write is deny VLAN 600.
Yeah. And also deny also VLAN and grant access to VLAN 500.
So allow VLAN 500.
Allow VLAN
Okay.
500.
All right.
Yeah. And maybe we shut other ports, right? That's not going to VLAN.
We still have the DMZ.
Yeah, but like, okay. Yeah, we deny. We have to deny VLAN 700 since it's just 500.
Okay, deny
network A and C to
deny DMZ. Okay.
Yeah, deny DMZ. Yeah. I think that's my own policy. And then the ports, I don't know.
So what port are we going to apply it on? We are waiting. Are you thinking?
So, yes, I'm thinking. So can we apply on two different ports?
You can apply on two different ports.
Okay. That means the VLAN 500 will be the only one that will have the only port that will have access to network C. Then other ones, the VLAN 500 I mean to say, which is for network A. Then every other one will have to block their port. That's what I'm thinking.
Now, the goal is to block network C, access to network A. We want the goal is to allow network C access to network A only. And we block other things, but network A should also be accessing every other thing except from network C. So network A's traffic should not be impacted by the policy that blocked access to network C.
Okay, so that means we'll have to block the interface that's leaving network.
Do you even know what to say?
we have to block the traffic that is coming out, not the one that is going in, that is coming out from.
On which interface? Let's decide the interface first, then we talk about the direction. The interfaces we have on, you said we are going to configure it on the multi-layer switch alone. So if we configure it here, This multi-layer interface has VLAN 500 interface and VLAN 700 and VLAN 600, and then the physical interface here. So which of these interfaces are we applying the policy?
I think at this point, it's not the physical interface because you need to go in first, just the coming out, right? So, but those one are layer 2 switches and they are on trunk.
The layer 2, the interfaces here are layer 2 interfaces, so don't worry about the interfaces here. I'm telling you about the logical interface that exists here that is powering the inter-VLAN routing, which is interface.
So that would be the physical interface.
The only physical interface that you need to consider here is this one, because this is the layer 3 interface. But these guys are layer 2 interfaces, so don't bother about them.
Yeah.
You bother about this one, which is a G0/1 and VLAN interface 500 and VLAN interface 600. These are the 3 interfaces you need to bother. And network C or network A belongs to network 500. So interface VLAN 500 is what is responsible for network A.
Yep.
So tell me.
I don't know. So I don't. Since we are not considering the layer 2 switch interface, like I don't know.
Who wanna help him? Samson, you can help him?
Because we cannot block the physical interface.
Has he jumped out?
Again, ourselves.
Samson, are you there? I mean, he's sleeping. People in class. Okay, Godswill, help him. Sorry, Simeon, help him.
Okay, so we're blocking the G0/2 of the second of the VLAN 600, the VLAN 600 interface.
VLAN 600 belongs to network B.
Yes, network B. Since we don't want the network to reach VLAN 600, only have access to VLAN 500. So we're going to be putting the policy on the VLAN we're going to be placing the policy.
First of all, let's start with the policy he said. Is the choice of device, is that correct? Is the policy is correct? And then before we talk about the interface. So he said we're going to configure it on the multi-layer switch, and we're going to configure a policy to deny VLAN 500, deny VLAN 600, allow VLAN 500, and deny DMZ. So is this order? Also consider the order, because remember, this will be processed in the order. Is the order right? Is the policy right? Is the device where we're going to configure it, is it right?
Okay, the first order should be the VLAN 7, the DMZ.
First of all, to deny DMZ.
Deny DMZ first. Yes. Okay. So when traffic passes through the first router closer to this interface, closer to the source, he stops at this DMZ. Then from there, it goes through this multi-layer switch that has access to.
You can configure the policies, but the application comes when you apply it on the interface. So the policy can exist. If you don't apply it on the interface, it doesn't kick in.
Okay.
Just have that at the back of your mind while you write this policy.
I think we're just going to place the policy on the 2 interfaces, which is the one going to DMZ and the one going to VLAN 600.
Great policy, super. Be application.
Ma?
What do you say? I say we need to create policy on.
We are going to deny VLAN 600 and also the DMZ too.
Okay, we already have the policy here that says deny DMZ and deny VLAN 600, and then we have allow
Please, I
500.
cannot talk now, please. I will be following, but I cannot talk, please.
Simeon, go on.
So those are the two things I think we should do. We deny access to this DMZ first, then after then we deny access to 600. So it would be I don't know how to call it, maybe out. Yes, it should be out.
On which interface?
Out on this the first interface should be G0/2.
This one?
No, we have.
Is it this one?
No, not this one. We are making use of the router and the multi-layer switch, so both of them. We're going
So
to
we are
get
configuring the policy on both.
both. Yes,
Okay.
both.
Configure on this and the router. Okay.
Router too. Yes, ma'am.
All right. Okay. So now application.
So the application will be on the G0/2 that goes through the DMZ. The middle
This
one.
one?
No. The center.
This one?
No.
This one?
No, ma.
Oh, this one.
Yes.
Okay, so we were gonna apply it on this interface.
Yes.
Okay. In what direction?
Out direction.
Okay, so apply here on the out direction. All right.
Okay. Then we also apply on the G0/2
On the multi-layer switch.
on the multi-layer switch also. Yes.
This is the only physical interface here, which is G0/1.
Okay.
Remember that there is inter-VLAN routing here. So we have interface VLAN 600 and interface 500.
And we create a sub VLAN there. It will be the interface, this physical interface dot the VLAN.
We already have that created already. It's already existing.
You know, we have two VLANs inside the multi-layer switch, right?
Yeah.
So what I'm thinking is we apply the policy on the sub VLAN for VLAN 600.
So you apply the policy on VLAN 600.
Yes.
Okay, so let me type that. Apply on VLAN 600. In what direction?
Out direction too.
Out direction. Okay. All right. Is that all we need to do?
So is there anything like sub interface like we can, or should it be just VLAN 600?
We don't have any sub interface here. We have virtual interfaces VLAN 600 and VLAN 500.
Okay, yeah, that's it.
And VLAN 600 belongs to network B. I hope you know that.
Yes, ma'am.
Okay.
So that's all from my side.
Okay, let's go. Gospel, do you have any opposing, or even if you have, let's implement this one first and see if it solves our problem. So our goal is, this is network C right here. We are trying to block network C from accessing DMZ, accessing network B, and allow it to access only network A. So let's set up this policy and see if it fulfills our mind. I'm going to type it out because I'm going to do a lot of copy and paste. Or you know what? Let's just type it out. So I'm on the router right here. Let's do that. En config T. So I'm going to do access list. Let me do access list number 20. So first of all is the deny DMZ. So do deny DMZ network is 10. No. DMZ is 172.16.30.0. Wildcard will be 0.0.0. I think that will be 192 minus 255 minus 192. 255 minus 192 will be giving me 63. So that would be the 63 right here. And then we set up the other one. Access list 20. We are also denying 600, which is 192.168.50.0. I have wildcard is 0.0.0.31. I believe so. And then they now allow the other one, which is access list 20 permit, try permitting network A 10.10.10.0. Subnet mask is, sorry, wildcard is 0.0.0. I think we arrived at 127 the last time. Okay, so those are the rules. Do show run. This is the rule we have. This is the 20 rule we configure, these 3 rules right here. So we denied network, we denied DMZ, we denied VLAN 600, and then we allowed VLAN 500. So now let's go to application. On this router, we agreed we are applying this on, but before we do application, let's configure it here because you say we're going to configure it here as well. So let's do that. En config T to access list. Let's use access list 40 here. Do the same thing. Deny DMZ is 172.16.30.0, 0.0.0.63. And then we have access list 40, deny 192.168.50.0, 0.0.0.31. And then access list 40. Permit 10.10.10.0, 0.0.0.127. Okay, those are our rules configured. So let's try to start up some communication first. So I'm going to start a communication from here to network B. From here, do a ping -T. Network B has 192.168.50.10. So we expect this traffic to drop when we set up the policy or when we apply it. This one should drop. Then let me ping from, I'm pinging from network C to network B right now. So let me ping from network A to network C, which should continue working if we apply the, which one is this one? If we apply the policy. So I have ping -T. Network C is 10.10.100.10. Continue. So this communication, we expect to continue functioning if there's a policy that is blocking this guy. A policy is blocking this communication. Which policy did we apply somewhere? This is 10.10.100.10. I mean, this is .5. My bad. It's .5, not .10. So this is .5. Okay. So .5 is working. We expect this guy to continue working when we apply this, but we expect this one to drop. This one is for network B. So I expect this one to drop. I expect this one to continue functioning once we apply the policy. So let's go ahead and apply the policy. So starting from this guy, we agree we are applying it on this interface in the out direction. So let's do that. Go to interface G0/1. Sorry, interface G0. Do show run. I need to take out the one I have initially here. So let's take out this one before we apply another one. Or we can apply it and then it will take it out. I think should be able to take it out without me taking it out by myself. G0/2. So go to interface G0/2, apply a IP access group. The policy number is 20 in the out direction. Do show run. Let's make sure it took out the old one. Yeah, it took it out. Okay, so we applied here. I didn't establish any ping from here to here, but let's do this one first. So let's apply this one. You say we're going to apply on interface 600 in the out direction. So here, let's go to interface VLAN 600 and apply IP access group 40 in the out direction. Okay, moment of truth. Let's see if anyone dropped. Okay, this one dropped, which is expected to drop. Okay, and this one is still functioning, which is what we expect to continue functioning. And I can guarantee you that this guy also dropped. This guy won't be functioning. If I ping it from here, ping 10.10.100.5, this communication shouldn't be going. It should be telling me request timeout all true. So this seems to achieve what we want to achieve. Good job, Simeon. If we did achieve what we want to achieve. So, but now let's confirm that no other computer is blocked, because we still want network A to access network B and DMZ. The same thing applies to all. Let's make sure that we are not over blocking somebody somewhere. So this is network A. Let's make sure network A is still communicating to every other person. So if I ping 192.168.50.5, are we getting a response? Okay, so we are reaching network B. Let's try DMZ. Ping DMZ is 172.16.30.5. Good job. We are still reaching DMZ. So let's try from network B, which is this guy. We want network B to still, which traffic is this one? 10, who is 10.10.10.5? Okay, 10.10.10.5 is network A and is obviously still responding. So this guy can still reach network A. And we ping DMZ. DMZ is 172.16.30.5. Uh-oh. Uh-oh. It looks like we overblocked though. As you can see, network B cannot reach network A. And I know the reason why we are not reaching it. Can you think about something in this policy? I wanted to correct that when I was typing it, but I said, let me leave it. But can you tell me, what do you think is kicking in here and blocking this? Which of this policy do you think is blocking network A, sorry, network B from reaching DMZ? Network B is not reaching DMZ. So VLAN 600 is not reaching DMZ, which is not part of what we want to block. We want to allow that traffic. We only want to block network A and network C. Every other person should be communicating, but now we are over blocking. So what do you think we did wrong here? Anybody can tell me.
I think it's the interface that we blocked. The G0/2 that we blocked.
It's not the interface.
On the interface.
It's not the interface.
Okay.
We missed something when we were configuring.
Okay.
We missed one line of command when we were configuring, and that is what is blocking that communication. What do you think we are missing?
Is it that maybe you deny before you allow?
No.
Okay, we didn't permit VLAN 600. So I don't know.
You are close. You are close to it. But I wanted to use a more general word for that. I mean, if we enter the command to permit VLAN 600, that will work to some extent, but there is one thing we could do to alleviate it all. Something is causing the blocking for this, even though we did not enter any policy to block network B from accessing network C or DMZ. We didn't put any of that policy, but yet it's been blocked. Because the policy we have here is traffic that are sourcing from we put traffic that are sourcing from, what did we configure, by the way?
Traffic that are sourcing from VLAN A.
So we denied DMZ, denied VLAN 600. Obviously, that's why it's been blocked. So we denied VLAN 600, which is network B, and we applied it on this interface. So of course, it's going to come here and block the traffic.
Yeah.
So there are different ways you can achieve this, right? You follow the longer process for this by blocking each of these networks, right? When what we could have done was write one single line of policy, or let's say 2 lines of policies. We could have just did this, deny network C. Can just did network C and permit any. Could have just done these 2 lines of policy and it will still do the work. Because if we do this and we apply it here, it will drop the traffic that are sourcing from here, and then it's going to allow everything else. If you also do it here and apply it on both interfaces, both VLAN 600 and VLAN 700, both of them in the out direction, we are still going to achieve the same thing. So this one, you went the direction of blocking from the destination part, why the destination become the source in this your rules. Because we had no reason to block 600 or DMZ. Our goal is to block network C, which will be the source from accessing here. But here we blocked individual networks, applied it, but then we are now over blocking. Because we apply, even right here, this one we apply here now. I didn't wonder why, okay, I was gonna wonder why network A was still accessing network B, because it's not supposed to. Then I remember that we did not apply the policy on network A interface. It was only on network B interface that we applied the policy. So that's why it's not kicking in for network A. Otherwise, we should have overblocked if we try to apply this on network A. But if we wrote this policy, deny network C, and then permit everything else, apply it on this interface, as you said, apply it on the same direction on VLAN 600 and VLAN 500, we will achieve our goal. Does that make sense?
Yes, ma'am.
Does that make sense?
I'm trying to understand
You're trying to make sense of it.
because I will deny network C since we want to be communicating network A and network C.
It's just one network is what we're interested. This, if you modify this policy, you will achieve the same work, but this will take you writing more rules to achieve this. But it's very straightforward one is just these 2 lines of policy. Then you now be strategic on where you apply it. But this will do the same job that we're trying to achieve. Configure it on both routers, apply it on this interface in the out direction, apply it on VLAN 500 and VLAN 600 in the out direction. We're already at the top of the hour. We are 15 minutes past time. So ask your questions. Let's round off.
I think the 2-line sentence is even more confusing than what Simeon and I, that long route is even explanatory.
The what?
The longer route is even explanatory. Like the 2-line sentence is even confusing.
It's explanatory, but it denies more than required. It denies more than required.
This is the most difficult course.
You mean ACL?
Yes. Very difficult. That one.
It's all about understanding, translating the requirement into commands. This one may be explanatory, but if you also look at it critically, considering we are doing standard ACL, you see that we are blocking more than we need to. Because, and also when we apply it, if you would have applied this on this interface, maybe, let me see, if you deny DMZ, sourcing from DMZ, so it will be traffic sourcing from here, going from here will be denied. Then 600 from here, if going from here, will also be denied. If you apply it on this interface in the in direction, sorry, in the out direction. But I want to see traffic coming from here and from here can source from here, going to here. And this guy can source from here, going to here. If we had applied this policy in the in direction on this interface, just this interface alone, we would have still achieved what we want to do. So configure it only on this guy and apply it in the in direction here. We'll still achieve that goal. But one thing we need to include here would be, instead of doing allow 500, you can do allow any, so that you can cover for implicit deny. Because our goal is to block just these 2 networks. So if we block that 2 network, we can allow everybody else. If we wrote this policy, apply it on this interface in the out direction, we will still achieve our goal. But if you write this one, you need to write it here and apply it on more interfaces. So you see, this one is easier, but you're going to apply it on this interface in the out direction. So anything that is coming from here, anything that's coming from DMZ and coming from 600 will be blocked once they are entering this network. Once they are leaving the router and entering the network. it will be blocked. But you're not going to be applying it to all interfaces. You're just going to apply it right here, and you'll still be fine. So any of these two policies will do the same job. It all depends on where you are applying it. That is what makes it different. Questions. Okay, let me stop recording.
Ma,
Go
this
ahead.
is still standard, right?
Yeah, this
You have
is still
not done
standard.
extended.
No, we are not.
Uh-huh.
We do extended either
That's
tomorrow or
where
next week.
that's where it's getting more complicated. Where you have so much address and so much network, deny particular address or network.
Yeah,
Then
that's where you use extended. Extended is more flexible. It gives you more things to work with. Standard is a little rigorous because you don't have much to work with. You only have the source IP address to work with. So it makes it more time for you to set up the right policy, applying the right interface and all that.
Thank you.
All right. Let me stop recording and then I'll